Hi YouTube, as you just saw, I was watching something online and I was kind of falling asleep. This has been happening with me a lot these days. And in hindsight, I believe this also happened with me a lot during my college days. Due to the current pandemic, whether students or professionals, all of us are bound to interact more and more with content online, whether it is online lectures or trainings. And most of us are guilty of falling asleep sometime or the other during the training. But that's the problem. What is the solution? Can we build something which can prevent us or help us not sleep during an online lecture? If yes, how much time would it require and what will be the skill set required? Let's find that out in this video. So the most basic idea behind detecting whether we are falling asleep or not is to detect whether we are blinking our eyes or not. But then we always tend to blink our eyes. Well, a prolonged blink can be indicative of sleep. Well, you can argue that it's not the only indicator or maybe not the most important indicator of sleep, but it's a good starting point. Then the whole problem becomes centered around detecting whether we are blinking our eyes for a certain period or not. And this can be very well handled by something called as a facial keypoint detector. Well, that can be a mouthful at first, but it is just a simple machine learning model to track all the different key points on our faces. Let's see that in action using something called as tensorflow-js. And it is a famous JavaScript package from Google, using which we can build different machine learning and deep learning models. Specifically, it's a JavaScript version of TensorFlow. So I have the repository of TensorFlow open on my system, and you can see that there's a lot of cool stuff which the amazing TensorFlow team has put up on this repository. So there's Blaze Face, Body Pix, and Face Mesh, Hand Pose. These are different models you can use to do different things. Like Hand Pose can be used to detect hand gestures. But for now, we'll be using something called as face landmark detection. Let's click on that. In this subpart of the repository, we can see a page which will give us a glimpse of what facial key point detection is. Basically, it's some key points of your face mapped on your faces. Interesting, isn't it? So you can see two people turning their faces around, and their facial key points moving with their facial expression. So this is quite an interesting and accurate model which we can use to predict different key points on our faces. And especially we'll be interested in the key points around our eyebrows. In this repository, the team has given instructions or code to install the package and use different functions provided in this API to use this model. And this is one of the most important figures on this page, which gives us the location and the numbering sequence of different facial key points detected by this model. A better version of this image is available inside this repository in this image. So if I just open it, you can see that we have numbers given to every key point. So yeah, that's a good view that's a good zoom view at the key points. So let's just clone this repository and see how we can extract some code out of this to make a version of our own, but with certain modifications in order to prevent us from sleeping. So let's see this in action. So to build our code, we'll be using one of the most famous deep learning packages from Google called TensorFlow. Specifically, we'll be using a pre-trained model from TensorFlow-js. TensorFlow.js is nothing but the JavaScript version of the TensorFlow package. And in this repository, we can see a whole lot of cool stuff uploaded from the TensorFlow team, which contains different deep learning models trained for various kinds of tasks. But for now, we'll be considering ourselves with face landmark detection. In this face landmark detection page, we can see a couple of people turning around their faces and facial key points overlaid on top of their images. And you can see how accurate and how cool this prediction looks like. Using this, we can build all sorts of cool applications using facial key points. And this page also hosts how we can install this package and how we can use different APIs from this package. And this is probably one of the most important images which we'll be referring to in this repository, because this contains the serial number provided to all the key points. And this shows nothing but all the key points with a triangulated mesh on top of that. So let's go ahead and clone this repository on our system, and let's see what all can we use from this repository. While that is downloading, let's check out what all different components are available to us within this face landmark detection demo. So here we have an index.html using which we'll start the execution of our code. We have an index.js, I think, which holds all the business logic for this application. And as you can see, it contains a lot of JavaScript code, and we'll have to wrap our head around all this code. And then there's only a triangulation.js, which contains some constants which are used to print that triangulated mesh we just saw in the image. Let's check our download, and yeah, it's complete. I'll also go ahead and create a repository in my account, which we will be using to host all the code which we create during this video. So let's call this blink detector. And this is a demo repository for code which helps us from sleeping in online lectures. I hope that's descriptive enough. Let's go ahead and create that repository and clone that as well to our system. It says we cannot spawn this one. So yeah, I missed the clone command. This should do the trick. And yep, we've got those repositories on our system, and here they are. And let's just quickly add these folders to our workspace within VS Code. So we have all the code here, and we'll just be concerned with our face landmark detection within that demo. So let's check this index.html. So this index.html looks quite basic to me. We have some script tags here, some styling, and some body. So let's go ahead and run this index.html in our browser to see how does this page look like. Okay, so it doesn't run anything because there's some error in the JavaScript file. So we'll have to fix this, and then we'll be able to run this code. So instead of that, let me just check. There is a demo version available, hosted somewhere on Google API. So let's check that and see how should this be running on our system. Whoa. So after some patience, this is what we've got. So, hey, you can see my spooky face here with that triangulated mesh overlaid on top of my camera feed, and this scatter plot showing all the key facial points in 3D space. This looks amazing. Like, it's really cool. But this does not serve our purpose, so we need to modify or tune this code to our purpose so that we can make an application which would give us some kind of alarm when we blink our eyes for some duration. And just to see, when I close my eyes like this, you can see that the key points near my eyes get very close to each other. And I would not be able to see that, but you should, because I'm closing my eyes when I do that. And we'll be using this very logic to make our blink detector. So let's get going. So the very first task for us would be to replicate this code on our local machine. Because as you saw earlier, when we ran the index.html file from our local machine, it did not run and it was giving us some error. And the reason behind those error is that this code has been built to run using Node.js. And that would be clear once you check out the index.html file. And here you can see that different packages are being imported here. And this can only run when we are running it from a Node.js backend. But here we want to run the code from our browser only, and we don't want to indulge into Node.js coding. So we'll have to make some modifications. But first, let's just go ahead and copy all the required files into our repository and start editing the code into our repository. So we'll copy the index.html, index.js, and triangulation.js files, because those are the only files which we'll be needing for our work. And let's copy this here into our repository, and we close this, and we'll just be concerned with this one. So let's check our index.html. And this index.html is basically a very simple one, because it just contains a couple of script tags, a body which has basically the canvas and the video player, and the div for the scatter plot which we saw earlier, and a couple of other JavaScript imports. But we'll have to add some other imports as well, because as you see, there are few packages being imported, and we want to use them from our browser. So we'll have to add the script tags for those packages in our index.html. So let's go ahead and do that. So the very first package which is being imported here is the face landmark detection package. So let's go ahead and import that. In our homepage for the face landmark detection model, we have all the URLs required for this package. So let's just go ahead and copy this and paste it in our index.html below the dat.gui package. And let's go ahead and comment this one. The next one is stats.js. So we'll just go ahead and search it on the npm repository. So looks like the script tag is not given here for this package, so we'll go ahead and download the source code from the GitHub repository itself. So this is simple. We just copy the whole code and paste it in a new file called stats.js. We won't need this export statement because again we are not using Node.js backend, so we'll just remove this export statement from here, and we'll save this, and we'll add the import for this file also. Cool. This does the job. So let's go ahead and comment this one. We have added this as well. As you can see, this one is done, and WebGL backend is also done. So we can go ahead and remove this one also. We won't be needing other backends, I hope. So we'll comment them for now. But if we get any error, then we'll go ahead and import that. So we have commented this one. So I think this should be also committed, because else we'll get an error saying that this is not defined. And the last import is the triangulation constant. So within this triangulation.js file, there's just one constant which is being used. So instead of importing this as a file,
let's just go ahead and copy this constant as a whole and just paste that in at the start of our index.js. So this should do the trick. Cool. So let's see, let's go ahead and execute this index.html and see what does it look like now. Cool. So this went fine. I think we got there are no error basically. There are no error basically. So let's just close this tab and allow our webcam usage for this tab. And fab, we have a working page. So we have successfully ported all the code which was there on this page to our local repository, and now we have the facial key point detection model working without the Node.js backend. So now we're all set up for the project, and we can go ahead and implement the core logic of our project, which is to detect whether we're blinking our eyes or not. So let's see how we'll do that. Okay, so before we start coding our business logic of whether we are detecting our eyes or not, I thought it is worthy to just quickly walk through all the components and all the different functions which are there in the index.js file. Because if we don't know what are we dealing with in that file, we won't be able to hack into the code and make it do what we want to do. So let's quickly walk through that and understand where can we plug in our piece of code to make, to extract the relevant information from the facial key point detection model and make it into a blink detector. Cool. So this is just the triangulation constant which we copied from the triangulation.js file. And then there are a couple of, constants defined, basically number of key points, number of iris key points. So the number of iris key points are basically the red key points on this scatter plot, which are basically the key points related to your iris, and all the other facial key points are marked in blue. So let's go ahead and on the way I'll keep annotating the functions with helpful comments so that anybody reading the code later on would be able to understand what's in that function. This is nothing but calculate Euclidean distance between 2 points A and B. Going forward, this is a draw path function, so I believe this one would be responsible for drawing all these paths between the different key points. So let's just add the annotation, draw path between given key points. These are some of the constants defined which would be used later in the code. Again, some constants, we need not bother about that. Then I think this constant needs a bit of explanation. So this is the state constant, and this tells us which backend are we using, what are the number of maximum faces we want to detect within a frame. So if we make it 2, we'll be able to detect multiple faces within the same frame as well, just like in the example here. So here we have 2 faces, and that means we would have to make max faces equal to 2. Triangulation mesh, that would toggle whether we see a triangulated mesh on top of our faces or not. So all these state variables are basically to control this little GUI, which is again controlled by the dat.gui package, and all these options present here on this GUI are basically being controlled using the state variable. So I hope that helps. Then there is this simple function which sets up that GUI. That's what it does, and that's all. Basically, it just adds all these little widgets on our page, using which we can control how our output looks like. So if I just uncheck that, the triangulated mesh would go off. If I uncheck that, my iris points are gone. If I uncheck that, my scatter plot is gone. So all these options are basically in order to control how our output looks like on the screen. So yeah, going forward, this function is basically to set up the camera feed in the browser, and this basically creates a stream variable in which a webcam stream would reside. And this function, I believe, is probably the most important one, because this is the render prediction function, and this function renders the output of our facial key point detection model on top of our camera feed. So this is probably the most important function which we are going to be concerned with. And there's this condition within this function. Once we've got the predictions using the model.estimate faces, and we check whether the predictions is a valid prediction by checking its length, and if the prediction length is greater than 0, we go ahead and create all our triangulated mesh and all our plotting. So this is the point at which we want to add something from our business logic and make sure that once the predictions are calculated, we take the predictions and implement some business logic to generate this blink detection logic. So I'll just comment here, add business logic there. Cool. Let's move forward. So all these lines of codes are basically to print the predictions on our browser. So this is being generated by all these lines of codes. And after this particular function, there's a main function. This basically sets up the backend and sets up the DAT GUI, calls the setup DAT GUI function, calls the setup camera, and calls the prediction function. And yeah, so this is the main function essentially. Cool. So we want to hack this code right at this point when the predictions have been loaded and it's a valid prediction. The length of the prediction is greater than 0. That's where we want to jump in. Let's just call our function business logic and pass the predictions to this. And we'll define this variable somewhere above so that we have global access to this variable. Cool. And also we'll add another file called as controller.js within this within our folder, and we'll add all our business logic in this particular file so that we don't clutter this already huge index.js file. So in order to make this work, we'll have to add our script tag in our index.html for our controller.js. So let's move to controller.js. Okay, let's think what all do we want to do within controller.js, and then go ahead and implement that. So first of all, we want to get the relevant point on our eyebrows. Cool. And we want to create data structure which will hold these points. Then we want to calculate distance between points on our upper eyebrow basically and our lower eyebrow, so that we can check whether the distance between these points is decreasing or not when we are blinking our eyes. And we want some mechanism to see the variation in the distance when we close our eyes. So we want to see how this distance varies when we close our eyes, because only when we'll be able to see that variation in the distance, we'll be able to figure out at what point we want to have a threshold which will say if the distance between our upper eyebrow and the lower eyebrow reduces by this more than this threshold, we want to call that an eye has blinked. So I think these are the 4 essential things which you want to do in this file. So let's go ahead and start writing code for this. So as a starting point, let's just make this predictions variable as a global variable, because this is the variable we want to make use of. And we also want to see what all things are we getting inside this variable. So I'll remove the const here and create this as a variable here. Now let's just go ahead and run our file to see whether we can access this variable or not. Okay, there's an error because we've not defined the business logic function. So for now, I've got to comment that and reload this one. Okay, so page is loaded fine. Let's see if we can access the predictions variable, and we can. And there are a lot of things which are there inside this predictions variable. There is an annotation attribute, there's a bounding box attribute, there is a mesh attribute, and there is a scaled mesh attribute. Now we want to use the mesh attribute or the scaled mesh attribute because these are the attributes which contain all the location for different key points on our faces. Now it's a question that what do these 63, 64 and all these points mean, and where are they located? So to get this key, we would use this meshmap.jpg which is available in the repository. So if we just have a look at this, and this is not getting viewed in full screen, so let's just download this image and check it. So we can see that points from 362 to 263 here and are basically around our eyes. So these are the points which we want to use for the left eye, and these are the points which we want to use for the right eye. One thing to note here is that this image is inverted. So the right eye of this image would be the left eye for our camera feed, because I am sitting like just opposite to my web camera. So that's a point which we should make note of. So we will access the 0th element of the predictions variable because everything is inside the 0th element, and then we'll access the mesh part. So inside here you can see you have an array of 478 elements, and those are all the key points. So if you just want to see a particular key point, let's say 350, then we can access the 350th element, and we get an array of 3 elements which represents the x, y, and z coordinates in this space where our key point is placed. So let's go ahead and add this to our controller.js. Before that, we want to uncomment this business logic function call and implement our business logic here. So before doing that, we want to create a couple of variables which would store the relevant readings. So let's go ahead and do that as well. So we have left eye readings and we have right eye readings. Okay, and then we have business logic equal to function predictions, and we want to store our left eye in a we want to create some sort of a distance measure between between the key points of our upper eyebrow and our lower eyebrow. So let's just say we have a function called distance, which we want to call, and we want to get the distance between predictions 0 mesh, and we want to get the prediction distance between the 385th and 380 key point. So which is one of the center key points of our left eye. So let's say 385, and we also pass in 380. Cool. So now we are storing the distances calculated between our upper eyebrow and our lower eyebrow in our left eye variable, and we'll do this similarly for our right eye. So let's say we want to use 159 and 145 for that. 159 and 149. Okay, but we don't have the distance function ready yet, so let's create that. So now we should have something of a distance measure between two given vectors, and then we will add these distance measure to our readings. So we'll say left eye readings dot push, and we'll push the left eye reading into that, and we'll do similarly for our right eye. Okay, this looks good, and so let's go ahead and see how this is coming in our index.html. Okay, let's reload this. Oh, there is a exception which is saying that right eye is not defined. Okay, let me check that. Okay, so we missed a variable definition here. We want to create this as right eye. Let's reload this. Cool. So now we have no errors. So let's see if we can access our okay, now we are getting this undefined kind of a thing added to our left eye readings, and that's because we have not returned anything from our function, which is quite lame. So we'll add a return statement here, which will be math.sqrt dx into dx plus dy into dy plus dz into dz. It's strange how you do lame things. Let's try that again. Okay, let's see if we have. Cool. So now we have some readings here, and you can see these readings are nearly constant around 5 or 4. So average would be around 4. So but we want to see this like we won't be able to track. So if I reload this again, you see that now 264 points have been added to this array, but we won't be able to make sense of this array like this because it's too many numbers. So why not go ahead and create a plot of all these readings on a line plot here, so that we can easily visualize how the curve looks like and where would we want to place a threshold. So the next part would be to add logic to visualize these readings. So for that, we can use an open source library called chart.js. So let me just go to this page and pick some samples. So inside the line chart, I want to take basic one, and yeah, so I have this line chart which has 2 lines, and fortunately we'll also want two lines to be there. A very simple line chart can be created using this one. Okay, so let's check that. I've added my chart.js code here, but I also want to import my chart.js library in my code. So we'll go ahead and do that. Inside my index.html, I will call script tag this should do the trick, and our chart.js should load fine. And so we have to add the data here. Let's remove this options variable here, and we want to add our data. Okay, we just want to pass an array of numbers, but it should be both like an x coordinate and a y coordinate. So let's go ahead and copy this one and paste it instead of our data variable. So now we have a sample data pasted in the line chart, and we can just call I believe my line chart dot render, and this should render fine. But we've not added this element to our index.html, so we have to do that as well. So for that, we want to use a library called canvas.js. So let's go ahead and check that. This is a library which you can use to create beautiful HTML5 charts and graphs. So let's see a little demo. So we want to use line charts, and we'll just take an example of a line chart. Okay, so we can just go ahead and copy this whole code into our controller.js, and we'll modify it later on. And we also would want to include this the link of this file into our index.html so that this can be called. So let's see if we can get that in the chart documentation. And okay, we get this right away here. So let's just copy the script tag and paste it here. We'll just paste it right after this one. Okay. And also in our controller.js, we see that we need a chart container to be able to print the chart. So we just add another div here right below our output div, and we'll call this chart container. Cool. So this should do this should add a chart to our code. So let's see, and let's reload and see what changes does this make to our file. Okay, so now we are getting a simple line chart added to our file, and we want to now put all the data which we are getting from our output predictions into this chart. So let's see how we can do that. Okay, now animation enabled is true, fine, that is fine for us. Theme and title, let's just call this distance between upper and lower eyebrows, and we have to modify the data basically. Left eye readings here. Okay, and let's just call our chart.render right here. So let's see what difference does that make. Okay, so we've got an error, but we cannot read the property get time of undefined, which is occurring at line number 39, which is this one when we are rendering the chart. And this says that we don't have get time of undefined. Okay, so this might be occurring due to the fact that we are only passing our y coordinates and not the x coordinates. So we might want to add a variable which would keep track of the x-axis as well. So let's go ahead and do that. Let's say it's just 0 here. Okay, so let's say we add both x val and left eye here. Okay, let's see if this works. Okay, do we have something here? Okay, now the chart is rendering fine, but there's no data which is appearing on our chart. So what could be the reason for this? Okay, so we want to load the data point as a dictionary, which is x and y. So but we have not done that. We've just added a dictionary without any keys here. So maybe that's the reason. So let's see how we can do that. Let's call this X, and let's call this Y. Let's call this X, and let's call this Y. So we'll reload that. Let's see. Okay, finally we have a chart which is being rendered, and we have our left eye nicely, the distance between our upper and our, so if I make my eyes widen, this distance should go up, and if I make my eyes narrow like this, it should go down. So this looks really cool. We have a graph and we're tracking the eye distance between our upper and lower eyebrow. Really nice. So let's go ahead and add another graph for right eye as well. So it will be a dictionary. This will be a list, and then a dictionary will be there. We want to have all the different attributes in present here. So let's go ahead and do this. Okay, so now we have every attribute present for both the data points. So we have type, line, show, legend is true. Name can be, we can change this to our left eye. Markers can be square. We don't need this one, and we are fine with the colors. So data points will be added using our left eye readings, which will be simply Y here, and okay, and yeah, we need, okay, cool. So, and then for this one, we say that this name will be our right eye. Color can be slightly different. We'll change this color to something else later on, and the data points will be added using our right eye readings. I think this should do. Cool. So it looks like we have our distances here, but the problem is we have both the values at a different scale, and we have both of them as same color. So let's see if we can change the color of these lines to differentiate between them. Move the color property from here, and maybe we can have a different color. Cool, this looks good. We have two different eye colors tracking our right eye and our left eye, but both of them are on a very different scale, and we need to see how we can fix that. Also, if you can see, when we were plotting only one graph on this chart, it was very choppy because because of the noisy disturbances of slight movements in our eye. So if I just close my eye, or if I just widen my eye, these distances would vary very drastically. So to remove those drastic movements and create a smooth movement, we want to have some kind of a smoothing effect on our readings. So we'll going forward, we will add the smoothing effect so that we get very smooth curves from our lines. And also, right now we're just taking distances between a pair of points, but we want to take an average of two pairs of points, which would further reduce the noise which is there in our reading. So let's do that, and we will simply do this by just adding another distance here, and just taking an average of that. So for our left eye, we'll use 385, 380, and 396 and 374. So we'll add 396 here and 374. And we'll take an average of these two readings. For our this one, we will take the reading of we have already taken 159, 149, and I think that's why we are getting a huge distance there, because we have misrepresented the points, which is 159 and 145, and we have added 149 here. So we'll make it 145, and we'll also add 158 and 153. So we'll add 158 and 153 here, and we'll take the average. Let's make it 386 and render it again. Okay, so finally we are able to see nice consistent plots here, and if I widen my eyes, they should go up, and if I close my eyes, they should come down. But still there is a lot of variation and a lot of choppiness in the curve, so we'll go ahead and apply a smoothing effect on these curves so that we get we can get rid of all those noises which are present in this curve. And to do that, we're just simply going to take a moving average of our readings. And how would we do that? Let's create two variables, left eye average and left eye right eye average, and we'll also create a smoothing variable which would tell us how much smoothing do we want. And we'll create a function which will smooth a given array by a given amount. So we pass an array, we pass a smoothing factor to this, and we'll be using two functions which are called slice and reduce. And what these functions do is basically array.slice gives us a slice of that array. So we will be taking the last few elements same to as the smoothing number. So if the smoothing number is 15, say, we take 15 last elements of that array, and we take an average of those 15 elements. To get the 15 elements, we're using array.slice, which is length minus smooth to array.length, and then we just reduce this to C, and we divide this by the smoothing factor. So this should give us a value which is a smoothed value, a moving average value of an array based on a smoothing factor. And whenever we have this reading and we have more than we have n number of reading where n is greater than the smoothing factor, we'll go ahead and smooth the array and add it back to our average arrays. So let's see how we can do that. So if we say array.length is greater than smooth, and here array would be our left eye reading, or we have our array.length greater than smooth, and here array would be our right eye reading. So we will go ahead and take smoothed versions of our arrays here. We will call the smoothing function left eye readings, and we will pass the smoothing number here as well. So this variable is called smoothing, which is a conflict because we have two variables called smoothing. So we'll just call this as smooth, and we will call this function here, and we will add these to our average basically. So yep, we'll add this one to here, and we'll do similarly for our right eye average. I hope we have made the variables right. Yeah, we've done that. So we will add the smooth right here. Cool. And now we will change these chart variables to our corresponding average variables. Now when we reload this page, are we getting something? No, we're not getting anything. Okay, so we have made some error then. Okay, so let's just change this one because we don't need this to pass to the graph, so we can just add our readings to this one and it should work right fine. Yep. So now we are getting our readings nice and smooth, and we see that our left eye, because I'm facing slightly, at a tilted angle to the camera, my left and right eye are having different values. But if I just keep my both eyes equally aligned to my camera, you can see that the curves nicely align. So let me just do that. And if I increase my, if I widen my eyes, the reading goes up, and if I close my eyes, the reading goes down. So now we are nearly there, and we just need to add a threshold to our readings, and we are good to go. So let's just find a way to add a beep to our code, and we'll just look for beep audio in JS. And I think Stack Overflow is there for our rescue, and we can just copy the simple function where this nice person has given us the solution. So let's just add this here. So this is our beep function, which we will use to play a beep whenever there is whenever this function is called. And we will put a threshold where threshold is equal to what should be our threshold. So for that, we need to observe our readings here. So whenever we widen our eyes, the reading shoots up to around 7 or 8. And whenever I close my eyes, the reading falls down to below 4. So I think we can comfortably put a threshold around 4. So let's say I put a threshold 4 and I put a logic here. If my left eye average, last element of my array, yth is below my threshold, and the same is true for my right eye as well. Say dot slice -1. Okay, let's see how this turns out. Well, it can still not read the property y. Now this is strange. And that may be because we have not added anything to left eye. So we want to have this condition within this if statement, and because only when we have added elements to, we've started adding elements to this array, we can check for that condition to be true. So let's go ahead and reload that. Okay. If I just look very straight into my webcam and close my eyes, I should be able to hear, and I hope you're able to hear the beep sound. And if I open my eye, the beep sound stops. So yep, we have a working prototype on our hand, and this is working quite nicely. You can add a few tweaks to this code, like switching off the mesh on our face, or adding a slider to modify the threshold which we are putting, or to do some few other refinements, and maybe add some heading or maybe some nice HTML so that our page looks good. But basically this is a bare bone version, and we have a good working model of a blink detector here. So if I were to watch anything online and I'm just falling asleep, my eyes are closed, I would just start getting a beep from my laptop, and I would wake up and the beep would stop. So this is the logic. But this is not a very perfect solution to this problem, because there are other factors as well related to sleep, and maybe we can train some other sophisticated deep learning models to basically keep a track of all the facial key points and learn what locations of the facial key point mean when a person, if a person is sleeping. And that would be a really nice solution. But that is, a topic of some other video. Cool. Thank you. Finally, we have created a model which would beep when we blink our eyes, and this can be used to prevent us from sleeping during an online lecture or training. And I will upload all the code which we have created during the course of this video to my repository, which is this one. So please go ahead and check that out and use the code to create new and fun stuff. One of the examples which I can think of is to create a yawn detector by monitoring the points around our lips, and if the distance between the upper and lower lip point increases by a threshold, we say that we have yawned. And you can make a cool game out of that, where you can track how many times did you yawn during a lecture and compare it with your friends. So go ahead and use this code to create new and cool stuff, and I will catch you in the next one, where we will discuss some other pre-trained model and how we can use a pre-trained model to for our business logic by just making some nice and quick modifications to it. So if you like this video, or if you got something out of it, please give it a like and subscribe to our channel, because we'll be endeavoring to bring new videos to you related to pre-trained machine models. Thank you.